Hey guys, Saion Gupta here, founder of 10x Holder Kids and an official Guinness record holder for the youngest computer programmer in the world. And today we are going to be solving some fun, interesting triangles Olympiad questions, and it's going to be very fun. So let's get started. Alright. So the first question is that prove that sum of any two sides of a triangle is greater than twice the median with respect to the third side. Alright, so over here we have a triangle, alright, and we have to show that the sum of any two sides, let's say AB, let's take AB. So we have to show that AB plus AC is greater than, right? So it's greater than 2AB, right? So we have to show this. Alright, so how can we do this? So the first thing that pops into our mind is proving that ADB is congruent to ADC, right? But this won't work. So if you try that, I'm going to tell you what will be the outcome. You will have AB plus BC plus CA is greater than 2AD. But we have to show that two sides is greater than, basically we have to show that two sides when added together gives us that it's greater than 2AD, right? So this won't work, that when we show that these two triangles are congruent, then it won't work. So what can we do? So over here what we have to do, we have to do one construction, right? So we have to make another triangle. So let's just take our scale, let's just go here, and we have to make a triangle such that, basically such that if you point this mark this as point E, then you have to have AD is equals to DE, right? And we are going to see why in a second. All right, and let's just join EC, right? So let's just join EC. Okay, so we have drawn a triangle such that AD is equals to DE. Now how is that helping us? So in the end, right now what we have to do, we have to prove that DEC is congruent to DAB, right? So what we have to show, we have to show that DAB is congruent to DEC. Why that? So that EC we can show is equivalent to AB. Now you might be asking why we have to show EC is equivalent to AB. If we show EC equivalent to AB, we know AC plus EC will be greater than AE, right? Because two sides of a triangle when added together will be always greater than the third side. So when EC will be AC, essentially what AB, essentially what you will be doing, you're going to do AC plus AB is greater than AE, right? And that AE is basically 2AD. So we're going to see all of this in practice. So first, to prove ABD, let's just start with D. So to prove triangle DAB is congruent to what? So what now? DAB, so we have to show it's congruent to D, triangle DEC. Alright, so we have to show it's congruent to triangle DEC. Now to show that it's congruent to DEC, what we are going to do, we can see over here that BD is equivalent to DC, as AD or AE is a bisector of it. So we can see that BD is equals to DC, right? So BD is equals to DC, right? Next, what can we see over here? Do you see this angle? Aren't these vertically opposite? Let's just remove this D from here. Oh, sorry. Alright. Let's just write D over here. So aren't these angles vertically opposite angles? And we know that vertically opposite angles are always equal. Now we have shown that BD equals to DC. Next we can show angle BDA is equals to angle CDE. Now what else? We just drew DE such that it is equivalent to AD. So AD is equals to DE. So now what congruency rule will we apply? Obviously SAS. So through SAS congruency rule, we have shown that triangle DAB is equal or congruent to triangle DEC. Now once we have shown this, we can say that EC is equivalent to AB by CPCT, right? So by CPCT. And now when this happens, we also know that we have a triangle ACE, and in this triangle AC is plus EC is greater than AE, because this is a property of triangles that when we add two sides, it is always greater than the third side, right? And now we know that AC plus EC is also equals to AC plus AB, because EC equals to AB, we have shown over here. EC is equals to AB by CPCT. So AC plus AB, and what is AE? It's essentially just AD plus DE, and these two were equal. So we can say that basically AD plus DE, AE is AD plus DE, and because DE and AD are equal, we can say that AE is AD plus AD, and AD plus AD is equal to 2AD. So what we have shown, we have proved that AC plus AB is greater than 2AD. How did we show that? We basically did a construction. We drew a triangle, right? Then we proved the ABD congruent to DAB congruent to DEC. When we proved that, we got AB equals to EC. Then we used the property of triangles that sum of two sides is always greater than the third side. When that happened, basically we were able to prove that AC plus AB is greater than 2AD. Alright, so this was our first question, right? Very cool. And let's just erase all of this. Let's just get rid of all of this very quickly. And right, so now we have our second question, that is ABC is a triangle. So ABC is a triangle where angle B is 2 angle C. So basically let's take angle C to be X. So everything will be very easy when we take angle C as X, right? So angle B is 2X, right? D is a point on BC. So D is a point on BC such that let's just take our ruler over here, such that AD, right? Such that AD bisects angle BAC. So it bisects angle BAC, and AD is equals to CD. So AD is equals to CD. Prove that angle BAC is 72 degrees. It's not 720, it's 72 degrees. Oh, sorry about that. Alright. Okay. So we have to show that angle BAC equals to 72 degrees. How are we going to show that? So one very important thing that is given over here is that AD is equals to BC. And when basically now we know that ADC is an isosceles triangle. So when ADC is an isosceles triangle, the base angles are equal. And as we have taken angle C as angle X, we are going to say this angle is also angle X. Right? Now what about this angle over here? Let's see. So basically we were given that angle B is to angle C. D is a point on BC such that AD bisects. So bisects word is very important. So it's bisecting, meaning this angle that is on this side is equal to this angle, and now this angle is X. So this angle will also be X, right? So over here we get this angle to be X, this angle to be X, this angle to be 2X, and this angle to be X. And now we have this one whole triangle, right? So I'll just bring this up. We have one whole triangle, right? Alright, I'm not. Yeah, so we have this one whole triangle. So now in this triangle, we can use the angle sum property. That is, sum of all angles is 180 degree. So angle B is 2x, right? Plus angle A is x plus x, that is 2x, plus angle C is x, that is equals to 180 degree. Now 5x equals to 180 degree, and x equals to 180 degree divided by 5. So 180 degree divided by 5 gives us 36, right? So x we get 36 degrees. And what was angle BAC? Angle BAC was equivalent to 2x, as we can see over here, x and x. So angle BAC is 2x. X is 36 degree. So angle BAC is equals to 2 into 36, that is equals to 72 degree, that we had to prove, right? That we had to prove. And this is the proof of both the questions. In the first question we had to do some construction. In the second question we just had to apply logic. And these Olympiad questions were very fun to do. I hope you liked the video. Thank you and see you next time.